Hello, so this is the last video in the set. I'm going to make it slightly bigger and see if I like it any more or any less. Okay, so we have all the way up to 70. So we have a little bit less than 20 more problems to go over. I think we'll be good. But let's start with example 52. All right, so we need to get our like terms together. So first thing I'm going to do is get these two r's together because they're on the same side. The next thing I need to do is bring this whole 2r to the other side. Well, to do that, I got to think of how to get a 0. That's how I get rid of it on the side. And since this is a positive 2r, the way to get rid of it is a negative 2r. I got to do the opposite. And if I do that to that side, I have to do it to the other side as well. These go to 0. And 8r minus 2r, negative 8r minus 2r is a negative 10r. All right, I'm going to continue over here. All right, so you know I don't like it written that way. I'm going to flip-flop it. The 10r still remains negative. The 16r still remains negative. I flip-flopped it correctly. Now I can properly see that the 16 is being subtracted from the r, and the way to undo that is to add it on both sides. And then the last thing I see is that the negative 10 is being multiplied to the r, so I need to divide that. And in the end, r is going to be a negative 2. Very good. All right, so we're going to do the same thing with this one. We're going to get as much done in combining like terms on the actual sides before we start doing it on both sides. So I can get these two together. Now remember, there's an understood 1 in front of this a. So negative 1a minus 6a is going to give me a negative 7a. I owe $1, I owe $6, altogether I owe 7. All right, so you know what, let's move this 7 to the other side because it doesn't matter which one we move. So I'm going to move this 7. So if my work looks a little different than you because you moved the 2, not a biggie, just as long as we get the same answer. I'm going to go about it just a slightly different way to show you guys different ways you can do it. So the negative 7 is negative, so to make it a 0, I got to add it because I'm moving it. And the reason I chose to do this is because it's going to get rid of that negative, and I kind of want to get rid of that negative. I don't like working with negatives as much. 2a plus 7a is 9a. I don't like the way this looks. I'm going to flip-flop the sides. Did not change anything, just the side it was on. And now I'm going to identify that the 3 is being subtracted from the a. So to undo it, I need to add it. All right. And the last step is to divide both sides by the 9. 9 goes into 63 7 times. And my negatives went away doing it that way. So you can look at it that way. You know, bring it to the side with the positive term that it's like with. Now I want to do something. These are long, but I'd like to evaluate and make sure my answer is correct. So I'm going to take my original equation, and I have multiple a's in this equation, and all of them are going to get filled with a 7. This is my check. Okay, I don't need the parentheses because it doesn't mean multiplication. This next one, a negative 6 times a 7, is going to give me a negative 42. 2 times 7 is 14. And now I need to get everything together on their proper sides. 60 minus 7, I'm just going to work left to right. If I take 7 away from 60, I'm going to have 53. If I take 42 away from 50, I'm going to have 11. One more thing I have to do is the other side. 3 take away from 14 is also 11, and it checks. So A is 7. It's the only number it can be in this situation because I have stuff on both sides of the equal sign. The only time that I say that this is a functionality of when x is 3, then the answer is this, is when we don't have stuff on both sides of the equal sign. All right, let's do this one. All right, the first thing I want to do is get these two together. That's going to give me 11t, and it's going to be negative. All right, I'm going to bring the 11t to the other side because that's going to make it positive. There's an understood 1 in front of here, which makes it 12t minus 5. I'm going to flip-flop my sides. Okay, I can now see that the 5 is subtracting the t, so I'm going to add it on both sides. This is going to help with my negatives, so I don't have so many. I'm going to divide both sides by the 12 because it's multiplying the t, and my answer is going to be 2. Now, if you had done it the reverse way, it would have also come out as a positive 2, okay? But now you don't have to worry about those double negatives and everything, so sometimes it's easier. All right, so let's go ahead and try to check it real quick. 2's aren't that hard. So I'm going to put a 2 in for every single t in the original problem. We're just going to do our multiplication from left to right first. Negative 4 times a 2 is a negative 8. Negative 7 times a 2 is a negative 14. All right. Negative 19 minus 8 is going to be an 11. And I'm not trying to get 2. I'm trying to get the same number on both sides if I put 2 in. 11 minus 14 is a negative 3, and 2 minus 5 is a negative 3. It checks. All right, we have some like terms. They're not beside each other, but we can still do them. Understood 1 here. So negative 3x plus 1x is going to give me a negative 2x. On the other side, I have a 6x and a negative 5x. That's going to give me 1x because I have $6, but I owe 5. I only have enough money for a can of pop. All right. I'm going to bring this to the other side so it goes to positive. So negative 2x plus 2x. It's negative, so I have to do its opposite. Got to do it to the other side, and I put it beside its like term because I can't add it to the 20. It's not like terms. I'm I'm going to flip-flop my sides because we all know that's how I like to view it. The 20 is adding to the 3x, so to get rid of it, I need to subtract it. Divide both sides by the 3. X equals a negative 9. Negative and positive make a negative answer. 3 goes into 27 9 times. All right, on this one I have a negative 2x. Oh, understood, positive 1x on this side. Okay, I'm going to show you a quick method of getting all your like terms together. Okay, if to be able to move something, and this is not different than the way we've been doing it, it's just quickening up the process. Okay, so up here what we were doing is if I wanted to move this negative 2 to the other side, I took its opposite and I added it to both sides, right? If it was a positive 2x, I would have subtracted 2 from both sides in order to move it. That's my opposite operation rule. I can do that all in one step, and I'm going to show you. And if you didn't solve it this way, if you want to keep solving like 55, it's okay. It's just the point of math is to keep getting quicker and quicker and quicker with your steps, because they're going to keep piling more steps onto you. The equations are going to get a lot more difficult as time goes on. So the more tricks you know, or the more things you know how to do to quicken the process, the better it is. So I have a negative 2x, positive 1x. This 4, to bring it to the other side, I'm going to have to subtract it. So I'm just going to put it over here as a subtract 4. This 3, if I wanted to bring it to the other side, I'd have to add 4. So I got rid of that, and that, which leaves me with the rest of the equation. I just put the rest of the equation the way it is. Now I can combine all these like terms at once. I just did what I would have done in probably 3 to 4 steps very quickly. And that's the point, is to practice doing the step the proper way and then to find shortcuts, because these equations get harder. And we don't want to take 2 sheets of paper to work out an equation. All right, so negative 2x plus 1x is a negative 1x. Negative 1x minus 4x is a negative 5x. Negative 5x plus 3x is a negative 2x. Now I have an equation I know, okay? So I'm going to add 5 to both sides. Divide the negative 2, divide the negative 2. 2 goes into 2 one time, but since I have that pesky negative, it's a negative 1. So bring that to the next page. All right, let's bring all of our y's over. So I have a 5y, a 3y. If I bring this over, it's going to become a negative 4y. I'm going to combine all this. I'm going to do it quicker this time. I'm going to do it all in one step. So 5y plus 3y is 8y minus 4y gives me 4y. And it's a positive. Let's flip-flop our terms. Now I can clearly see I have to subtract that 7 from both sides. Now I have to divide the 4 on both sides. Negative and a positive is going to give me a negative, and 4 goes into 25 times. We are getting there. almost to the end, 70 problems, and we are at 58. About 12 more. All right, so I want my 9W, my 2W. I'm going to bring this W from the other side and make it a negative W. That leaves me with a positive 36 equals 1. Okay, put all this together. 9 plus 2 is 11, minus 6 is 5W. The 36 is adding to the W, so I have to subtract it from both sides. Gives me a negative 35. Now I have to divide the 5. So 5 goes into 35 7 times, and because of this negative and this positive, it's going to be a negative 7. All right, so let's get our like terms together. So it's going to be a negative 3r minus 5r. Bring the 2r to the other side and make it negative. I still got this negative 16 equals positive 4. So let's combine these all at once. Negative 3 minus 5 is 8r, negative 8r. And then 2 more is going to give me a negative 10r. The 16 is subtracting the r, so I have to add it to both sides. Last step is because it's multiplying the r, I'm going to divide the negative 10, and r equals a negative 2. All right, let's get all these a's together. So I have a negative a negative 6a. If I bring this 2a over, it's going to be a negative 2a. Still have the plus 60 over here, and a negative 3 on the other side. Understood 1 here. So negative 1a minus 6a is a negative 7a. Minus 2 more is a negative 9a. The 60 is being added, so to undo it, I need to subtract it from both sides. Divide out the negative 9 on both sides. We haven't had this situation in a while, but 2 negatives make a positive answer, and 6 goes into 63 7 times. 9 goes into 63 7 times. All right, let's do it again. Let's put all our t's together. Going to bring that 1t from this side to the other. It's going to make it a negative 1t. Negative 4 minus 7 is negative 11. One more is negative 12. 19 is being added, so I'm going to subtract it. Should have been a 19. Divide both sides by negative 12. 2 negatives make a positive 2. I think I'm doing the same problems over again. Let me just look here. I think I might be. I thought the answers were starting to look familiar. So actually, we finished all these. And I did some over again in another way. And that's okay. That's just how we did it. Alright, so let's do distributing. Remember with distributing, that's where you multiply the number through the parentheses. So in this first example, 59, I'm going to be multiplying 2 by the 6x and by the 7. Now that plus has to stay in there because it's also the sign of our number. But I have to show that I'm going to multiply it through. 2 times 6 is 12x. 7 times 2 is 14. So here's our problem. The 14 is being added to the x, so I'm going to subtract it from both sides. And this is going to do a unique thing. We're going to see it here in a minute. 14s go away on the left. They also go away on the right. So anytime I see this situation, okay, where I get a 0 on one side, when I divide out the 12, it doesn't change anything. Okay, we have two different circumstances where you have a number in the denominator and a 0 on the top. That answer is 0. It's always 0. This one, though, where I flip it, is no answer. It's undefined. Okay, so the way I always remember it is I have 12 pieces of pizza. You say to me, I would like 0 pieces of pizza. I don't like pizza. And that would just mean you walked away with 0. So the answer is 0. But if I have 0 pieces of pizza and you ask me for 12, that doesn't even make rational sense. Okay, you can't ask me for something I don't have. That one is no answer. There's a mathy way of writing that, and we will go over that in a different class if you take any more of my classes. But that's when you start getting into functions. All right, so let's multiply this through. All right, so 9 times 3 is 27y, and 9 times 2 is 18. Again, 18 is being added, so I'm going to subtract it and watch what happens. Those go away. These also go away. Well, doesn't matter what I do. The answer is just going to be y equals 0. All right, we are in the home stretch. 8 times 9b plus 8 times 5. Got to distribute that 8 through and multiply it by everything. 8 times 9 is 72b. 8 times 5 is 40. Now I got to subtract 40 from both sides because it's being added to the b. Alright, now I'm going to divide both sides by 72 because it's multiplying the b. And b is going to equal a negative 1. 72 goes into 72 one time, a negative and a positive make a negative. Alright, distribute through the 5. 5 times 11n is 55n. 5 times 5 is 25. The 25 is adding the n, so I'm going to subtract it from both sides in order to get rid of it. Now I got to divide both sides by 55 because it is being multiplied, and n is going to equal a negative 1. Now when I just have a negative sign on the outside, remember that is a negative 1. It's an understood 1 there. So I actually have negative 1 times 6 minus negative 1 times t. All right. Negative 1 times 6 is a negative 6. Negative 1 times t is a negative t. And I have a double negative. Two negatives here. I got to make them positive. Remember your rules for signed integers. If you don't, I teach a crash course on that. Be sure to take it. I'm going to rearrange my problem and see that I need to add 6 to both sides because it's subtracting the t. T equals a negative 8. Again, I'm going to assume the 1, and I'm going to distribute it through. All right, so a negative and a negative is going to give me a positive 3. I have another double negative going on. These are going to go to positive. I'm going to flip-flop a little bit. And I'm going to see that that 3 is adding the x, so I'm going to subtract it from both sides. And x equals a negative 14. We are in the home stretch. 5 more to go. Okay. Negative 2 times 3x. Distribute my negative 2 through. Drop down my sign. All right, negative 2 times 3 is a negative 6x. Negative 2 times 5 is a negative 10. All right, so I have two signs here again. Okay, so when the signs are the same, it turns to a positive. But when the signs are different, it turns to a negative. It follows the rules of multiplication and division with signs. And if you take my crash course on that, I will explain that a lot more. It's very important that we don't have two signs back to back, because then we can't properly see what the constant term is doing to the variable. I mean, I could have said it was adding before, but actually what it's doing is subtracting. So now I can see that I need to add it to both sides. Now I need to divide a negative 6. 6 goes into 35 times, and it's going to be negative. Ugh. All right, let's distribute through this negative 3. All right, negative 3 times positive 5 is a negative 15x. And the negative 3 times the 1 is a negative 3. Two signs again, but this time they turn into a negative. So now I can see that the 3 is subtracting, so I have to add it. Now I have to divide the negative 15 from both sides. It's going to be a negative. I always look at it this way. 90 minutes is an hour and a half. How many 15-minute segments? So that would be 6. Because an hour has 4 15-minute segments, and a half an hour has 2. So my answer is negative 6. All right, now I have double distributing. So in this first one, I distribute through, so it's going to be 3 times the x and 3 times the 4, 2 times the x, plus 2 times the 10. Let's clean it up. This is 3x minus 12 plus 3x equals 2x plus 20. Let's get all of our x's together. 3x plus 3x. If I bring this over, it's going to be minus 2. Let's drop down what's left. 3x plus 3x is 6x minus 2 is 4x. The 12 is subtracting the x, so I'm going to add it to both sides. And now I'm going to divide out the 4. And that's going to give me 8. A positive because there's no negatives that I have to deal with. No different signs. 3 more. Let's distribute the 9 through. And the 5 through. Let's make this a subtraction. Actually, let's make it addition because I bet that's what I was trying to push, since that's the button it shares on the keyboard. All right, let's clean this up. Let's get all our W's together. When I bring the 5W over, it becomes negative. Write down what's left. 9 plus 7 is 16, minus 5 is going to give me 11. I'm going to add that to both sides. Divide out the 11. W equals 4. Okay, so I want to speed things up now. We've been doing a lot of these. We should be able to speed them up, okay? So the way I want to speed it up is instead of writing 6 times 2j, 6 times 6, I want to do them and write the answer. So we got to learn quicker ways of doing things so we're not using full pages of paper to figure out problems. All right, so 6 times 2 is 12j. 6 times, gotta write down my symbol first. 6 times 6 is 36. 4 times j is 4j. Write down my negative. 4 times 30 is 120. All right, let's get all these j's together. If I bring this j to the other side, it becomes a negative. All right, 12j plus 4j is 16j minus 4j. Just undoes that and brings it back to a 12. The 36 is adding to the j, so I'm going to subtract it from each side. Then I have to divide it, and I'm pretty sure I know, but let me double check this. Yeah, 7. So 12 goes into 84 7 times. All right, our last one. Let's see if we can do it quickly. So 4 times 9h is going to be a 36h. 4 times 2 is going to be 8. big H, which means it's not the same as these little h's. 4 times little h is 4 little h. 4 times 18, I'm going to put it underneath. It's going to give me 2. Then 4 plus that is 72. All right, let's get all of our little h's together. If I bring this over, it becomes a negative. All right, so if I take 4 away from 36, I get 32h. All right, I have some things going on here. I can't combine little h and big H, so I have two variables, two unknown variables, which means I can't solve this, okay? But we'll get it down as clean as we possibly can. The 8 is adding to the h, so I'm going to subtract it from both sides. And that's about as far as I can go, okay? So 32 little h plus 8 big H equals negative 80. Cannot solve just reduce. Kind of like our combining like terms because I have two different h's in that problem. All right, so that is all the example problems. Make sure to check out my other classes that I offer. I usually do it in the fall and the spring. The summer I don't offer as many classes, mainly just crash courses and fun math courses. So check out my other classes and let me know if you have any questions and need further explanation. I love to explain math. You are not bothering me to ask questions. All right, so I hope you all found this class to be enjoyable.